Hello students, whenever we see the problems of thermodynamic potential or problems related to the Maxwell relations, so we use this magic square. Using this magic square, so we can easily get the expression, mathematical expression for thermodynamic potentials, and we can write the Maxwell relations very easily without memorizing it. So for example, in this question, they have given you internal energy, and now the internal energy is the function of natural variable. So what are the natural variables? Natural variables are S, V, N. They are the natural variables for internal energy. So suppose if I want to write the internal energy, thermodynamic potential, so how can I write? So because you can remember this magic squares, which says good physicists have studied under very fine teachers. So in this way, you can remember good physicists have studied under very fine teachers, and you can remember this square. And now let us suppose I want to write the expression for u. So how can I write? Because the both side of the u, you have v and s. So what will happen? I will write the du, and now I have s and v. That means this will be dv. And now you have to write the conjugate variable. Conjugate variable is a variable which will give it the dimension of work or energy. So of course we have to multiply this by P. Now you have to see, while reaching to P from V to V, are you going towards the arrow or opposite to the arrow? If opposite to the arrow, there will be minus sign. And if you're in the side in the direction of the arrow, then the sign will be positive. Similarly here, you will be having, say, ds this side, and now you are going towards t, because s dt will be the unit of energy, and you're going, so you are going towards t, so this will be positive, so this will be t ds. So this is the expression for du when you write this in terms of its natural variable v and s. Here n is of course the constant, otherwise you can involve the s n also. And now we want to write, so this expression also can be written. If I know the first law of thermodynamics, I can write simply dq is du plus pdv, and this will be simply tds du plus pdv. And from here, this is from second law of thermodynamics, and you can write du also tds minus pdv. So here it is easy. Now suppose instead of suppose you want to write the f. Okay, so how do you write? You write the df. Okay, this will be always dv, and now you're going towards p, so this will be minus pdv. And now you have a t dt, and you're going towards s opposite, so this will be minus s dt. So in this way, you can write all the thermal potential. Similarly, you can also, using this magic square, you can also write the Maxwell relations. Now, that's, coming back to the problem, here energy is represented by E, so this will be dE minus PdV plus TdS. Now I want to find the temperature, so this T I want to find, so I can simply differentiate d versus ds, keeping the volume constant, and this will give me the T. And when I differentiate this one, this will give me 3b s square Vn, and this will be the expression for temperature. So option B is the correct answer. So this is magic square is very useful in thermodynamics, thermodynamics mathematics. So you should learn this one. So I'll stop here. Thank you. I will come with more this type of questions in my next video.